Okay, so now we will talk about problem number 10. Which of the following equations could be used to find R min, the minimum distance between the masses as particle A approaches particle B? So this is using the same masses from before, particle A and B. Particle A starts at x equals 2d and is approaching particle B with a velocity of v naught. So, since we are given that the potential energy of the system is equal to beta divided by r squared, r being the distance between the two particles, and that we must have a conservation of energy, and that the initial distance between the two particles is 2d, we can say that the initial kinetic energy, which is 1/2 mv naught squared, the particle B does not have any kinetic energy, so that doesn't need to be there, plus the potential energy, which is beta divided by r, which currently is 2d squared, and that all is equal to the final kinetic energy plus potential energy, which is equal to beta divided by r squared, and that r will be the minimum distance, because okay, so the initial kinetic energy is 1/2 mass times v naught squared plus the initial potential energy, which is beta divided by r, which initially is 2d squared, and that all is going to be equal to the final energy, right after the collision. So that will be equal to beta divided by r minimum squared plus the kinetic energy of particle A, 1/2 mv final squared plus 1/2 mv final squared. So the final velocity is going to have to equal v naught divided by 2 because of conservation of momentum. Since the masses are equal to each other, and initially one of those masses has a velocity of v naught, when that momentum is then transferred into the second when that momentum is then transferred to the second object, well, when the collision happens, the momentum is then distributed so that since it's twice the mass, it has to be half the velocity for the momentum to be conserved. So So what that gives us is 1 half mv naught squared plus beta over 4d squared as our initial energy in the system is equal to beta divided by r minimum squared plus, if we add 1 half mv over 2 naught squared, or v naught over 2 squared plus 1 half mv naught over 2 squared, we get m v naught over 2 squared. Just like that. And that is B.